You're going to be so relieved you watched this if the IV characteristics practical comes up in your physics exam this week, and I think it will. Here is everything you need to know. I'm Mr. Wells, by the way. Let's start with the purpose. It's to investigate the relationship between I and V, which is current and potential difference in 3 different components at GCSE. We do this to get these graphs. So in order to get these graphs, we need to set up a circuit with whatever it is we're testing out of these 3, as well as a means to measure the current and potential difference. Often, if it's a big question, you get some space to draw the circuit diagram, so this is how we build it. Think about it step by step so you're actually understanding. This is the component you're testing. Obviously, for any circuit, we're going to need a power supply. So here I've drawn a cell. Now, to measure current, we need an ammeter, and ammeters must always be connected in series to the thing you're testing. That means in the same loop. So ammeter in series to measure current. Then we need to measure potential difference. You do that with a voltmeter, and it must be connected in parallel to the thing you're testing, in its own separate loop or across the thing you're testing. Voltmeter in parallel to measure potential difference. Sweet, right now then, if we've set this up, what are we going to get? You'd only be able to get a single reading. We next need something in here that's going to allow us to get multiple readings so we can build these graphs that we need at the top. We need something that can change current. Remember, it's resistance that opposes current. So is there a type of resistor that you can change? Oh yeah, there is. Variable resistor, let's put one here. Remember, that's the one with the arrow. So the purpose of this is to change the resistance, which therefore changes current and allows us to get multiple readings. The more resistance you have, the less current you have. Like so. Sweet, so with this current setup, we will have been able to get one direction when the current's flowing one way. That's just the positive side of your graph. We also need to get the negative side of your graph. So how would we do that? You just need to send the current around in the other direction. So what is it that's sending the current around your circuit? You need to reverse the connections in that thing, swap it around. So you say, reverse the connections in the power supply. Then repeat the whole process, and that's how you get your negative values. We then go and plot these graphs. These graphs I've now labeled are graphs of I against V. That's how you say it. I on the y-axis, V on the x-axis. And from that, you can clearly observe these relationships. For a fixed resistor, we have a fixed resistance, which is why this is a nice straight line, directly proportional since it's a straight line going through the origin. For a filament lamp, you've got a nice straight, directly proportional bit in the middle at your low potential differences and currents. But as you go to higher potential differences, the line sort of plateaus. The reason behind that is because at higher potential differences, higher currents, you generate more heat in the component and therefore more resistance. If there's more resistance, that's going to stop your current from going up, which is why it flattens out, as you see right here and right here. Lastly, the diode, that's a circuit component that only lets current flow in one direction, which is why we see current in the positive direction, but none at all in the negative direction. And that, my dudes, is really all there is to it. I hope that helped. Let me know in the comments if it did. And if it did, that is well worth a like and a follow. Let me know if there's anything else you need a hand with. Best of luck. Believe in yourself. You've got this.